So recently we've been planning to do a new kind of collisions in the LHC as part of the heavy ion program, namely instead of colliding lead nuclei with each other, we plan now to collide protons with lead nuclei, which opens up a whole new range of physics prospects. For us in the accelerator team, this is quite a challenge because in fact the LHC wasn't designed to collide two different beams. We've implemented everything necessary in the LHC systems to allow all this to happen, and we've made some tests. We made some beam tests in 2011, and in 2012, in September, we made the first pilot run colliding protons with lead nuclei. And this was very successful, although the luminosity was very low and it only lasted a few hours. Alice and the other experiments got some very interesting results already from this. So we're very excited now about the prospects of the longer proton lead run that's planned when we restart the LHC after Christmas in January 2013. It will run for about 1 month, and we hope to increase the performance a few hundred times over what we did in September and provide a very significant data set to the experiments. This has been the work of a small team of people working quite intensely behind the scenes on preparing everything in the LHC and studying the beam dynamics. We've had just a few chances to actually test the beams together in the machine, so it's quite an adventure. We hope everything will work in January. We're sure it will work at a certain level, but we have to explore the potential performance of what will really be a quite new way of operating a collider. It's almost unprecedented, so we don't really have past experience to base our projections on. But we know that the whole heavy ion community is very interested in this, and we will certainly do the very best we can to provide them with significant data. To explain why it's not obvious to collide protons and lead nuclei in the LHC, one has to understand first of all that the particles have quite different mass and charge, which means that in the same magnetic field, which we have because of the 2-in-1 magnet design of the LHC, they therefore have different speeds and go around the ring at different frequencies. So the lead is a bit slower than the protons. You can fix this in a collider by displacing the orbits, making one go a little more to the outside and one more to the inside to compensate, but at the injection energy of the LHC, the lowest energy, this would displace the beams right outside the beam pipe, and we can't do it. We can do it when we finally get to collision energy. So we have to get through injection and the ramp up in energy with different frequencies. And that we can do because fortunately the LHC has 2 independent RF systems for each ring, so our colleagues in the RF group can tune the frequencies appropriately to accelerate the 2 beams independently. But what happens in this process is that the beams nevertheless see each other around the experiments in the parts of the ring where they're circulating in the same beam pipe, and there are still electromagnetic forces between the beams, what we call the long-range beam effects. These we always have in the LHC, but because the beams are moving with respect to each other, these forces are moving and being modulated in a complicated way, which it has been seen in previous accelerators has led to serious problems, losses of the beam, blowing up of the beam so that it would no longer be good for colliding, for example. So we have to face this. We believe, according to our calculations, that these effects will be manageable at the LHC, but so far we have still really to explore them experimentally. To give an idea of these bunches, in this particular scheme we will have 318 of them. We have a complicated spacing between the bunches of alternating 200 and 225 nanoseconds. This is because a scheme had to be worked out in the injector machines, the PS, the SPS, and the Lear ring beforehand, which would deposit the bunches in the LHC in such a pattern that the protons and the lead would have an identical pattern and meet up with each other and collide. So this is why we have an unusual filling scheme. We have 318 bunches. I think 276 of them should collide in Alice. which is now the same as an Atlas, the same as the other experiments. And LHCb will get 42. In each bunch of lead ions, we have around 10 to the 8 lead ions, maybe 1.2, 10 to the 8 on average. For the protons, we plan to start with a higher number, but a value which corresponds to a fairly similar amount of electric charge, namely about 1.5 times 10 to the 10 protons. We think that will work well, and as we start the run, we will increase the intensity of the protons until we possibly encounter some limits. 2013, the LHC has been stopped over Christmas, except for the heavy ion source and LINAC, which have been kept operating because they take some time to get up to their desired performance. We've kept them running. The rest of the complex is being restarted, and we will start the process of commissioning stable beam operation with protons and lead nuclei colliding. We have a detailed plan of all the steps that requires. There are a few more needed, for example, to ensure that the machine is properly protected, the collimation system is correctly set up, the optics, the beam optics has to be adjusted in new ways because of the shifts in the orbits to the outside and the inside of the ring, and so on. So it will take a little longer than it did in the previous lead-lead heavy ion runs, but we hope that soon we will be in business colliding protons and lead nuclei and exploring the limits in performance that we can achieve. Then later in the run we have to do a number of other special steps, for example reversing the direction of the beams, because Alice would like to have the beams coming, protons from the left and lead from the right, but then the reverse later for the second half of the run. And we also have to switch the polarity of the magnetic field in the Alice spectrometer, which also requires some other adjustments of the crossing scheme for the beams. So it's a very ambitious run. We have to be extremely efficient, go as fast as we can, but also very carefully and respecting all the rules that one must obey in LHC operation and commissioning. But we are optimistic that we'll be able to provide a good performance to the experiments.